All right, hi everyone. Hope your build is going well. We're kind of in the middle innings now. We're halfway through. Hope everyone's learning all sorts of stuff and enjoying themselves. My name is Sean Henry. I run product for Semantic Kernel and AutoGen, and I'm here with my colleague Salman, who is engineering manager for the agent service part of AI Foundry. So today we're going to talk about building your digital workforce, multi-agent apps with Azure AI Foundry. So this is going to be a very technical course. We got a lot of demos, code first stuff we're looking at. We'll spend a lot of time in Visual Studio. So I hope you guys are ready for that. But we'll start off with the slide. Probably who has not seen a slide like this like 10 times already, right? Like what is an agent? Yeah. So I won't spend too much time on this. You guys all know what agents are, I hope. Anyone not know what an agent is yet? I mean, I think there's all sorts of different definitions. But really, an agent is is an AI app that has connected to an LLM to make inferences, has instructions and context, and most importantly has tools so it can perform actions. Hopefully you've all seen this already. What I want to talk about though is how we kind of deconstruct this and get from very simple agents all the way up to complex multi-agent systems. So first of all, we can think of agents that actually don't have tools. Now, really, like a tool is what makes an agent. But there are times when you might actually use an agentic framework, you might actually use the agent service, and not actually have tools that you're connecting to your agent. So if you have a simple task, like you're summarizing text, we've all done this by making inference calls to GPT-4 or whatever. But there's cases where you may want to host this in the agent service or use tools like Semantic Kernel and AutoGen. And the reason for that is that you get state. You get that state stored if you want to make multiple calls. If you want to have that prompt stay persistent. If you want to observe the agent, you want to see telemetry, or if you just want to have the same API across all of your systems and be able to grow, start with agents and then build more complex agents and then multi-agent systems. So, it's a great idea to just start with these agent frameworks and use them in agent services and use them, from the beginning, because very quickly you end up growing into more complex single agent systems. And the canonical one that's up here is agentic RAG. So we've all seen RAG, where you do retrieval augmented generation over search. And of course, adding an agent to the mix can give you much better results. When you have an agent, it can take the human input from the user, can generate a bunch of queries, look at the text in natural language, generate a bunch of queries, do a search over that, over your vector database, return a bunch of results, and then synthesize that result together. And there's lots of places where you would use a single agent like this, and they can get very complex. You can give them lots of instructions, and you can give them lots of tools to use. But at some point, you'll often end up building a multi-agent system. And a multi-agent system is where you have many agents. Well, there go the cameras. All right, a multi-agent system is where you have one or more agents working together to solve a particular task. And things you can do with a multi-agent system is you can give it a very complex task to perform. So in this case, we're asking it to do some research and build a large marketing campaign. And so we have an agent that specializes in talking to the user. We have an agent that builds the plan, that's the coordinator agent, and then it talks to all these other agents and solves the problem and comes back with a solution. Each of these agents that it's using may be specialized into talking with a particular web service, doing searches, talking to a database, or executing code. So putting all these agents together enables you to build much more complex and reliable applications on top of agents. And we see data to back this up. So this is data where we've looked at single agent systems with models, in this case GPT-3.5, and then built multi-agent systems with them. And they get very similar performance now to the next generation model. So 3.5 based agent systems with multi-agents now become like 4. As we do the same thing with 4, this also scales, starts behaving more like 4.1 and 4.0. So this is kind of a great way when you build multi-agent systems is you can kind of get more performance. So you can use kind of older models, get the same performance. Older models, less expensive models, get the same performance as newer models. You can use newer models and get performance that you couldn't get with those models alone. And more importantly, you can kind of dial in your quality by building your agent system and having different agents collaborate together for a certain amount of time. You can kind of build a better quality answer out of your multi-agent system. So that's why we build multi-agent systems, is really to keep the agents on context, be able to solve complex problems with them. So So at Microsoft, we have a lot of different ways for building multi-agent systems, and they all kind of fit together on a spectrum. At the top end, at kind of the SaaS layer, we have Copilot Studio, no-code approach for building enterprise-connected agents. We have the PaaS service with Azure AI Foundry Agent Service, which allows you to have managed hosted agents available in the Foundry. And then we have things like Semantic Kernel and AutoGen, which allow you to build agents kind of much closer to the metal using your models and your vector stores and your tools directly in a pro-code environment. So what are we going to talk about today? So we're going to talk about building agents on Azure AI Foundry. And there's a lot of things you can do with that. You can see kind of the menu here, and we'll touch on a bunch of these things. We'll talk about connecting your agents to things like Azure AI Search and Bing for grounding. We'll talk about all the different models that you can use that we support through Foundry. We'll talk about the open ecosystem and how we have agents that connect together and how we connect agents to other services. But we'll really focus on two areas. One at the bottom, we'll talk about the Foundry Agent Service, which is where you can build and host your agents in your multi-agent systems. And we'll talk about the agent frameworks that you can build on top of agents hosted in Foundry or agents that are hosted elsewhere. So to kick things off, I will hand it over to Salman to talk about the agent service.
Perfect. Thank you, Sean. So I'm super excited to be here today. Just a few months ago, we announced public preview of the agent service at Ignite, and today we're making it generally available for everybody. One of the most important things we've been working on over the last year or so is to make the service reliable, secure, and interoperable. We already have tens of thousands of customers using the agent service to run production workloads, and we've been processing trillions of inference tokens and terabytes of vector indexes that customers are already depending on. So I'm very excited about the general availability so that you can actually build production workloads on top of this. So while we were working on all of the security and reliability aspects, there were three key areas that we were focusing on in terms of differentiation. One is around enterprise-grade security. So the agent service, by definition, actually is a stateful service, which means that we persist a lot of state about conversation history, about run execution, and we do these things so that we can simplify recurring complexity that you all have to deal with. So what we've done is we've made these state stores single tenant, which means that they live or optionally can live in your subscription, and you have full configurability of these resources through Azure policies and other controls that Azure already provides. One of the most important things that you can do on these resources is that you can put a virtual network, so you can actually contain what services can talk to those resources, and that provides you defense in depth on top of everything that you're doing. The second differentiation that we've done is around model choice. We've heard consistent feedback from customers around being able to leverage just not OpenAI models, but other models as well. And as you've seen from many talks, that we have over 1,000 models in our model catalog, and independent of the projection of enterprise-grade security and the hosted tools that we have, you can select any model from the model catalog and have the agent service interoperate across the model ecosystem. And then lastly, we've invested a lot around building hosted tools. So hosted tools is its idea that they are services that are managed by Microsoft, and you can just use them to provide value. And we've added tools like SharePoint grounding, which allows you to ground your agent responses through SharePoint sites. We've added Azure Functions integration, which allows you to have hosted functions running in the cloud and have the agent interact with the Azure function directly over the cloud as opposed to coming back down to the client. We've also invested in open API-based tools, which allows the agents to talk to any API that has a Swagger spec, which most do, and you can connect these agents to be able to read or use these APIs to make mutate state outside of them. We've also have Logic Apps integration that we're announcing, and some of these tools are in preview, but the service itself is in GA. And the last one that I'm very excited to talk about is a browser automation tool which will allow browser automation tasks through a hosted browser scenario. So that is our single agent story, right? An enterprise-grade, interoperable, secure set of service with tons of hosted tools and many more to come. And this gives you a cohesive story that you can go in front of your security organization with to say that this is our security model, and that satisfies the most strictest of organization, including banks and healthcare. But today, we are here not to talk about single agents. We're here to talk about multi-agents. And to talk about that, I want to make sure all of you have this sort of picture in your mind as we go through the demos today. When we design traditional software, we have complete deterministic process with deterministic outcomes. You control every aspect of the control flow, and you know exactly what's going to happen. In fact, there's a name when traditional software don't have determinism. It's called segmentation fault. Right? If you haven't planned for it, things happen and your process crashes. But on the other end of this is a probabilistic process and a probabilistic outcome, and these are multi-agent systems, where you're completely sort of relinquishing control over how the control flow works, and you're leveraging these LLMs to direct flow control. Now, obviously, we cannot live in this other spectrum, right? You can't build software systems that are completely probabilistic. You want predictable outcomes for your end customers, and I'm going to talk about how we will achieve that through a new service that we're going to be announcing today, which is in preview, called the AI Foundry Workflow Service. But to get to that, I'm going to sort of slowly make the progression. We want to start with the single agents, and we're going to go to this concept called connected agents. And to do that, I'm going to switch over to my demo, because I think we've had enough time on PowerPoints. So we're talking about connected agents. Now, all of you have built single agents. Single agents, you've given it power through APIs and tools. Connected agents is this idea that you use other agents as tools. So I'm going to go ahead and quickly create one. So I'm creating a new agent. And down below, you'll see this new sort of toggle that has this concept of connected agents. And all you're seeing here is essentially a list of all your existing agents within this project scope. So you can simply connect to your Bing search agent, give it a name, and you can provide instructions to this main agent that I'm creating now, agent 856, and say, trigger this agent anytime you need real-time information. And this works in conjunction with however the sub-agent itself is configured. So as you can see, when you're building traditional software, you don't write everything in a single main method. You break it down into different functions. Functions have single responsibilities. So sort of in that same mental model, sub-agents are those functions. They do a very small set of tasks. They are prompted. They're given tools that perform that specific task. And this top-level agent is then able to use that sub-agent to accomplish higher-level tasks. So I'm going to go ahead and add that. And I'm going to add one more. And I'm going to add this coding agent, give it a name, coder. You can use this agent for coding tasks. And notice that I'm not spending time mentally thinking about how the code execution agent is configured, what tools it has access to, what permissions it's given, how it's prompted. All of that becomes sort of the responsibility of that single function or the single agent that I'm now composing up. So go ahead and add that. And then now that I have this, I can just try it in the playground. Now, the beauty of this is that the API interface that you use to interact with a single agent is the same API interface that you have to talk to this connected multi-agent, because at the end of the day, they're just tools, so it works really nicely. So I can ask, what is the weather in Palo Alto, California? And notice I don't have Bing grounding set up. I don't have any of those tools set up. And yet, this top-level agent talks to this connected agent to hopefully give me an answer. And these are all live demos. I actually don't have anything recorded. As you can see, this works. So you can actually break this complexity down, and you get better precision and recall because these sub-agents can only view a narrow scope of the world rather than the entirety of things that would otherwise have to see. So you get much better control and precision. So that is connected agents. So this takes you from the world of building single agents. As you start to hit limits on them, as you start to add more functions and tools, you may slowly graduate into this concept of connected agents to provide you additional value. But this, again, is an implicit orchestration. What I mean by that is you are specifically not controlling the order in which these agents are invoked, how many times they're invoked, or what parameters or values that are used to invoke them. All of those things are sort of left up to the LLM to decide. And that generally works, but that may or may not be what you desire. So for that, I was going to show you a demo today around the workflow service, which is something I'm very, very excited about. So again, to mentally associate yourself, we're not recommending that you jump into building workflows right away. You build your single agents, you see what these limits are, you start to go into connected agents because all your tool chain, all your SDKs, they all work. So it's an easy progression to get to connected agents. And then if you start to hit limits within connected agents because of particular scenarios that you're trying to build, then you can sort of move on to workflows. And even workflows use the same set of tool chain, so it is an easy transition. So we'll talk about that today. So the class of problems workflow solves are where you want much more granular control over how the control of these agents happen and the data bindings that need to happen as you move through the system. So to give you an example, if you're building a customer agent bot, you don't want the bot to act in a way where I can log in and say, my name is Sean. And all of a sudden, the bot treats me as Sean and starts to act like I'm Sean and give me all of Sean's information. So there's particular data bindings that you want to guarantee that the model will not hallucinate and they work consistently throughout the stack. So those are things that you get out of the workflow service. And the second thing you get is that unlike other multi-agent systems like LangChain or Swarm, where they are essentially SDK offerings, you basically build multi-agents through code. We have a declarative system for multi-agents where you declare what your process looks like through Semantic Kernel's process framework. And once you declare it, you can publish it. And when you publish it, you get an endpoint that you can use to interact with that workflow. So with that context in mind, let's spend a few minutes looking at what this setup is. So to do this, I'm going to build a deep research multi-agent. Now, deep research, some of you may have used in ChatGPT. It's an option where the agent goes into doing research on the web, does follow-up research, and eventually, after tens of minutes of work, it produces a pretty comprehensive summary of that work. You can use it to research your next vacation plans. You can also research it to figure out many other complex tasks that almost produce publication quality work. Now, to do that, we have built this deep research agent using, or at least inspired by the AutoGen team's work through Magentic One, where they have this notion of teams where each block here is an agent that does something specific. For example, it can do research, it can gather facts, and it maintains this ledger of work where the planner, essentially given the task, plans a ledger of work, and as the work gets done, the ledger is marked as completed. And eventually, when all of the work in the ledger is done, the research is considered to be complete. Now, we're going to open source all of these workflows that you can then build on top of. And these are opinionated versions of things that we think how deep research should be done, but you can change them, you can mutate them, you can make them even better. And so to run this, the way we have this configured today is, let me go and close that. So we have this notion within the workflow service of sort of dependency injection, where the workflow can be given an instance of another workflow, and that instance can be injected with a set of properties that you can use to run it. So in this case, as you can see, this workflow has a single box. The single box is that deep research workflow that you saw earlier, and it accepts a certain set of inputs. For example, it accepts a set of team members and an instruction. The team members are the specialized agents that can do work. For example, it could be a research agent and a coding agent. So you can inject those team members to it, and you can start off interacting with it. So what I'm going to do now is, as you can see, I am connected to my Build 2025 project, AI Foundry project, and I'm going to deploy this. And what it does is it deploys this workflow into the service, and you get a managed endpoint that you can use to interact with this workflow. So this is the point that you're not actually building this in code, you're just declaring what your workflow looks like. Once that's done, so as you can see, there's a workflow ID that comes up, and I can go ahead and run it. When I run it, what I get is a chat experience directly in VS Code, where I am actually interactively chatting with this workflow. Now, our workflows have two modalities. You can interactively chat with them for interactive scenarios, but you can also do asynchronous workflows where you can run them, and they can run in the cloud for hours and days, and we will take care of hydrating state, persisting them, and rehydrating them when necessary, and doing it in a way that's durable so that you don't have to deal with that complexity. So to get this going, I'm going to just give it a task of studying the latest S&P report and generate a report for me. And this will take a while, so I'm going to just slowly kick this off and then move on to something else. But I want to show you that there's these events that happen, that the workflow is started, and it's going to produce a ledger of work, so it knows exactly what the plan is, and then other agents sort of pick up work from that ledger, and they do them, and ultimately this completes. So we'll see it when it's sort of done on the side. So I'm going to let this run, and in the meantime, because this is obviously a developer talk, I want to spend time showing you what it looks like building one of these workflows in code, because that's precisely what most of you will be doing. So to do that, obviously we can use semantic kernel, but I wanted to take this sort of a step further, where I'm using a classic sort of SDK to build these single agents, and then just for the multi-agent piece, I'm using the process framework. So if you look at my CS project, for the process framework piece, I'm using this semantic kernel package. And my code is pretty simple. So this is a very simple setup. I've got a teacher and a student, so two agents. The teacher agent is configured to give preschool level math homework to a student, and then the student is asked to do that homework. And if they get it right, you progress into the next state, and if they get it wrong, they're asked to continue to retry until they finish. And then once I create those agents, you can see that there's this build operation that I can do on it, which builds the process, your business process automation. So here is where I'm using process framework. So if you've been to Scott Hanselman's talk yesterday, he used the exact same SDK to build a linear process where he automated sort of his podcasting flow. I'm using a different kind of process to have these two agents talk to each other. So this brings up another interesting point about process framework, is that unlike other multi-agent systems where there is sort of official support for conversation models, where you have two-way chat or group chat or handoff, here we don't have those notions. We work off of events, and with events you can model any type of conversation as long as you raise the right events with the right payload. So event-based programming is something that we've been doing for decades now. So it's sort of bringing that same concept into multi-agents. And so here I've got two agents that are configured external to this method, and they happen to be creating two specific threads that they are using. So you can see this term scoped. What this means is that these two agents have a narrow view of the world. They get to see only the things that they are operating on. Now, this is just a choice because of the problem that I'm trying to solve, but I could be trying to solve a problem where I have shared knowledge, which would be effectively what group chat is. Because group chat is this notion that every agent has universal knowledge of everything that's happening, whereas this is sort of a two-way chat. So you can model a lot of these conversation states using very simple states and transitions. So once you do that, you build this process and you can publish it. And when you publish it, you get a workflow ID. So these are sort of virtual identifiers that you can use to execute tasks on top of. So the key point to take away here is that the process isn't actually building, you're not writing code to define your multi-agents, but you're writing the process through code. And once you do that, we fall back to all the existing APIs that we have seen before, create, thread, and run. And instead of running a single agent, which would be the parameter here, here we're giving it the workflow ID, which is the multi-agent. So that is something we also spend a lot of time optimizing on, where we want to make your transitions very simple. We don't want you to move to a different stack, a different programming model. You can stay on the existing programming model and make minimal changes to switch into this next thing. And then I pass in a user message, and then I start printing these streams as I get back. So let's go ahead and quickly run this. And this is all real, so none of this is recorded. So I'm hoping this comes up. And as it's coming up, we can go quickly check what is happening with the other agent. So as you can see, this is the multi-agent that created a ledger. It created a plan. On step 1, to gather data. Step 2, to analyze the data, execute code, compile the report, and these would be the deliverables. So this is quite nice. And then you can also see that the Bing grounding tool was used. It was used to do a specific search about latest S&P and performance in May 2025, which is the month we're in. So you get a lot of observability through our stack. So you can see exactly how the tool interactions are happening, what inputs and outputs are provided to the tools. They all sort of show up directly in VS Code. You obviously could do this in the Foundry portal too, but this is where you are, so we just natively connect to that. And eventually, when all of this work is done, you can see there's a coder agent that was pulled up to actually do some coding work. In this case, it was given a bunch of different industries and sort of their performance over time, and a plot was asked to generate. And we used our code interpreter service, which is a hosted tool, to generate that plot. And eventually, after all of this work was done, you get sort of the visualization, and ultimately, I think the work is still happening. So we'll leave it be for now, and we'll go back to this. So now we're back to the two-way chat student-teacher, and I'm just going to say go, because it actually really doesn't matter what I say here, because and this is this idea of having much more granular control over the flow. It really doesn't matter what I say because the teacher and the student are directed to work in a very specific way. So I'm going to just start that, and you will see that the student comes up and says, I'm ready to answer your question. Teacher, what should I do? The teacher says, this is all real, so maybe it's thinking. I'm not sure. We'll give it a few more minutes. All right, here's your question. 3 apples, you got 2 more apples. How many apples do you have in total? And then the student says, let's try figuring out this math. And it does that. It's like five apples in total. And then it goes back to the teacher for correction. So the teacher then checks the math to make sure that the math is correct. And it is, so it says, yes, you're done, and then it deletes the user thread that I was on. And then I can finally hit enter. I can delete those 2 teacher agents and the workflow, which is the ephemeral. All of these are ephemeral entities. You can create them, use them, and then delete them whenever you're done. So that was the demo of workflow agents. So let's go back here just to make sure this actually completed. It's still, the task has not been completed, so it's working and instructing other workflows to do stuff. And you can see some of them will fail because I may have exhausted my tokens usage for the time being, but there's sufficient retries in place to try and complete the task. And then the last thing I wanted to show is that we've been also working very hard around interoperability around A2A. So Google recently announced a protocol for agent-to-agent communication. And to show that off, what I'm going to show you here is a demo where I've got an agent that I've created, in this case, agent ASGZA, that has some tools and things involved. And this particular project, if you look at its dependencies, has everything A2A. Azure Identity to obviously authenticate with Azure services, but everything else is just A2A client, A2A HTTP. But because our agents starting today is going to be A2A compatible, what this means is you can actually interact with them through the A2A protocol. So these are all A2A constructs. You create a send task request, you wait for the response, and you print it. So if I run this, I should hopefully see that I can interact with this agent using the A2A protocol. So, and then we'll extend this further into our workflow service itself. So our workflow service will not only be able to interact with single agents that are designed by us, but single agents that live in other clouds. So you can then interoperate across the cloud platforms. And as you can see, the agent responded with, I'm doing great, and thanks for asking. And this was all through the A2A protocol. So, thank you. And with that, I am going to bring over the JM family to talk a little bit about how they've been using our multi-agent stack to provide value to their organization. Welcome, John.
Salman.
Nice to meet you. Amit, nice to meet you. So tell me a little bit more about how you found value in using multi-agents within the JM family organization.
Yeah, definitely. So interestingly enough, one of our biggest use cases was actually within our own technology organization. So for those of you who might not be familiar, JM Family, it's a $22 billion privately held company. Our businesses include, we're the largest independent distributor for Toyota in the world. We do captive automotive financing for Toyota customers in the Southeast US. And JM&A Group business has finance and insurance products that we provide and manage through auto dealerships across the country. Now, all of these business units are in massive technology transformations all at the same time. One of our biggest challenges was the inputs our engineers were getting to execute those technology transformations. So things like requirements, user stories, even though we have published standards and guidelines, the level of granularity, the form, the format, varied wildly across teams. This turned out to be a perfect opportunity for agentic AI. This was producing everything from defects downstream to just countless of hours spent going back and forth, trying to get clarity on what actually could have been more clearly outlined up front. And that's where our captive product development entity, Mosswell Technology, stepped in and built a tool to bring this capability through multi-agent to our product owners, our business analysts, quality analysts, as essentially a team of AI assistants to help generate the inputs to give our engineers what they need to do best, which is build great software.
That's awesome. And what were some of the return on investment on using this stack?
Yeah, I mean, not only did we see the process time to create these inputs shrink by 30 and even upwards of 40%, but just the time saved in meetings. And I know how much we as engineers absolutely love sitting in meetings, so people are probably heartbroken. But that time could actually be spent like engineering, novel concept.
That's great, awesome. And then any key learnings, any takeaways that you want to share, Amit?
Interestingly, there's a lot of key learnings. I'm going to, if I spend time, I can just keep talking about it. So starting from, one of the learnings is you need to, when you start any of the use case, you need to be very precise what you wanted to achieve. Make sure you have a clear roles defined for these agents, and you need to test these agent service as individually. Now, talking about platform, Salman has talked so highly about this platform. I must say, we have leveraged pretty much everything from human in the loop to going back to the agent interaction, 4 or 5 agents interacting with each other successfully, as you can see on the screen. Now, one thing I wanted to highlight about this platform is we have looked at various other platforms or frameworks like LangChain, and in fact, one of the things was AutoGen. One of the challenges we faced over there was how do we host these services? It's always being a challenge. Managing that session, threads, data, and users is always been an issue. And thanks to Microsoft bringing this agent service as a platform for us, where we worry about business use case rather than worrying about the infrastructure. Human in loop has become very seamless. It was very easy. As you can see on the screen, there are 4 or 5 agents running around. My demo is not as fancy as the newness which being introduced, but there's a lot of easiness. You worry about configuring FDL, which is the YAML type configuration, rather than writing a code.
I would say just the last thing, outside of the technology, or in addition to the technology, just the multi-agent paradigm itself is a lot easier of a concept for our users to grasp. So historically, Gen AI retrieval methods, it's been seen as a bit of a black box, but with multi-agents and having very specifically designed and intentional purpose-built agents that work collectively with our users, it's just opened up a much wider dialogue of how we can leverage AI in the enterprise.
That's great. Thank you. Thank you, Gen family. All right. And with that, I'll hand it off to Sean to show off a lot of nice semantic kernel stuff.
All right, thanks, Salman. Yeah, so let's move over from talking about managed agent services, and we'll talk about our client agent orchestration frameworks and how you can use those with our managed services. We're over here, that's right. So, within semantic kernel, we have a lot of the same capabilities that Salman talked about for building multi-agent systems. I already talked about, and Salman talked about, kind of these LLM-driven applications where the LLM is in charge of flow control and decides which tools to use, how to execute the plan. But then also having the need for process-driven flows where you have a lot more control over which agent executes in which order. And these kind of things, you need to look at them and decide what is the right application for the problem and the solution you're trying to go after. And in cases, you may want to have composability between these. So you can see in the one on the right here where we have a process-driven flow that's very directed, but within it we have some agent-driven flow, some LLM-driven flow where you have this writer and critic agent talking back and forth. So all these things are capabilities that we have within semantic kernel, which is our open source agent framework for building agent applications and orchestrating AI systems. And I will quickly get into a demo here. Let's take a quick look at how we build agents with semantic kernel 1.3. Here we go. Okay. So I'm going to kind of follow that same pattern that we had before. We're going to do first like a no tool agent, the most simple agent that you can build. And you can see here it's just about 3 or 4 lines of code. So if we look here, building our agents, we can we create our agent, we connect it to our chat completion agent type within Semantic Kernel. And this is the case, Semantic Kernel, we support connections to all sorts of different agents. This can be a chat completion agent, which means you're bringing your own model, you're bringing your own connections and your own tools, or it could be a managed agent, it could be an agent hosted in the Azure agent service, the Foundry agent service. It could be a Copilot agent that's living in the Copilot stack. It could be a responses agent from OpenAI, could be an agent from AutoGen, which is our research framework for multi-agent systems, or it could be an agent from something like Bedrock for AWS. So you can take all these agents and you can connect to them with Semantic Kernel and you can ask them questions. So in the case of this agent, we're just asking it something very simple. We're asking it to compose a haiku about Semantic Kernel. So we gave it these instructions, and we asked it for a response. Just a single response in this case. We're not having a conversation. So we're using this almost exactly like an inference API. And that kind of goes back to what I was talking about of in cases where you start with an agent system, even when you're just doing responses, it means you can grow into more complex things as you go forward. So we got a nice little haiku here. Code that learns and grows, patterns weave a mindful core, Semantic Kernel. Great, beautiful. Let's talk about real agents. So building real agents, with more capabilities, code very much the same in Semantic Kernel, but we've added a few new lines. So we've added these plugins, we've added a kernel object, and we've added arguments. So what are those? So first of all, our plugins, these are our tools. This is where we connect our tools and other capabilities. So in this case, I'm connecting with a tool that I've created in code. I could connect to OpenAPI from here. I could connect to MCP, connect to other agents. I'll show that in a second. This is where I put these in the plugin. In the kernel, I configure things like telemetry and filters and things that I can see what's going on with my system. And then arguments, I tell the kernel how to handle that data. So let's look at menu plugin first. So menu plugin would be something where normally you would connect this to a database or a data store. And by the way, all these samples are in Python. I have the link at the end. We also have all this stuff in C# as well. I'm going to go back and forth between .NET and Python a little bit. So don't worry if you're a .NET person or a Python person. I got you covered. We've created our menu plugin class here, and then we can annotate it with these kernel function annotations, which now tell Semantic Kernel to take these functions and stick them in the prompt that we give the LLM and tell it that your agent now has these tools to use. The other piece we're doing is with the settings, we're asking it to output in response format menu format. So instead of getting a natural language response, we're going to get a response in structured data. And then finally, we're adding this filter. So the filters are what tell us what tools calls we're making, what things we're asking the LLM to do, and ultimately this is where we'll hook up our telemetry. So we'll run this agent, and this is an agent that answers questions about the menu, and we're asking it what is the soup special and its price. So this is like one of those composite questions. There's 2 pieces to it. It needs to call back into our system twice. One to get the list of specials up here, clam chowder, Cobb salad, chai tea, has to identify which one is the soup special, then call back in and figure out what the price is. So we can see here, if we look at our output, our plugin was called with get specials. It's called with context. And the response gave us 3 specials, return that string. And then our plugin was called again, this time with the menu item call, and it replied with replied with $9.99. And then the LLM took those 2 responses together, and instead of generating natural language, which sometimes you want when you want to send that directly to a human, to a user, you want natural language, but sometimes you want structured output. So in this case, we're building structured output. Okay, so that's how you connect tools. You can connect all sorts of things to Semantic Kernel, and I'm actually contractually obligated to talk about MCP. So very easy to add MCP into Semantic Kernel. Actually, MCP is great. Probably the most important thing in the last 3 or 4 months that's happened in this world, in kind of the AI and agent world, and definitely something you've invested in.
MCP versus agents. everybody's talking about?
Yeah, which one's more?
Yeah.
Well, we did the full SEO in this topic where we're talking about, we got agents,
Yeah.
we got MCP, we're gonna do A to
got
A
all
and
the
a little, yeah,
titles.
exactly. We got everything. That's why you guys are here. Okay, yeah, so MCP, you know, a great way to surface tools and build them and connect them to your agents. Very easy to do. I'll just run this sample real quick. This is connecting to the GitHub MCP server. So there's all these servers available. If you're not super familiar with MCP, there's these services available. You can connect to them. Semantic kernel can be a client. We can plug it in just like we saw before with that menu plugin. We can plug it in directly to our agent, and then now it has access to all the tools that the semantic kernel server, that the GitHub MCP server has available to it. So I can now check up on my team, and I can see you know, what are the top issues they're working on right now. And we can look, we can see what's going on. Okay, look, we got a new issue. Oh, missing index and function code. We've got to get on that one. So this is all happening under the covers. I just had to give it a natural language request here. I asked it for what are the latest 5 issues in a Microsoft semantic kernel repo, and it was able to return this without me having to figure out the API contract with GitHub. This is a really powerful way to use MCP. You've probably seen a lot of MCP being used with like Visual Studio Code and Agent Mode. And GitHub, and Copilot Studio agents as well. And now you can use it with semantic kernel. One of the things I do want to point out, I don't have time to run the demo for it, but what do you think is happening now with all these MCP servers? There are way too many of them. And so your agents now have like thousands and thousands of tools to use, and they break. Your agents can typically only handle most models, you know, 10 to 20 tools. So something that we have a sample for in our semantic kernel repo, I encourage you guys to go look at, is actually taking all of your plugins and running a semantic search on them first. Put them in a vector store, and then figure out what are the best set of plugins to give to your agent, something that can really help with the performance of your agent. So there's a little nugget for you as you're building your agent systems. But you guys paid for multi-agents, so let's look at multi-agents. Okay, so as Salman mentioned with like connected agents, you know, very easy to add agents in semantic kernel. Here we have 3 agents we've created. We have a billing agent that focuses on kind of billing issues. We have a refund agent focusing on refund agents. And then we have this triage agent that kind of looks at the incoming request from the user and decides which of the agents it wants to use to, you know, resolve that request. And the other thing you'll notice here is there's 2 different types of agents. So we have our chat completion agent, which we've looked at. Oh, that's not what I meant to do. There we go. We have our chat completion agent that we've looked at before, and we've given it some instructions. But these agents up here, we've only given them this ID. And that's because we've defined these agents in the agent service. So I can hop over to the portal, or I can use the Visual Studio extension, and I can see my agents here. I have my refund agent, and I have my billing agent. And I can manage these all within the portal. This is a great way to get started with multi-agent systems. You can put your agents in the portal. You can give them prompts. You can connect them to Bing grounding. You can connect them to OpenAPI. You can do all that stuff in a managed way. And then you can build a multi-agent system with semantic kernel. So I'm going to run this, but I'm actually going to run the UI version here. I really like using a tool for UI when I'm developing stuff. I really like to use Chainlit, which is a nice tool for Python. And what you'll see is we've connected the agents up as plugins. So we have our triage agent, and it's using those 2 agents, our billing agent and our refund agent, as tools. And when this runs, I can ask it, I think I got a query here that I like. Here we go. So I'm going to ask it another composite question, you know, two things that need to be researched here. I'm going to say I was charged twice for my subscription last month. And can I get one of those payments refunded? So hopefully what's going to happen, and typically happens, these are pretty good systems now. They're getting pretty good with their tool calls. We're now making tool calls to billing agents and tool calls to refund agents. These are both happening in parallel. And we can see here the response that we get. So we got an input into the billing agent, you know, from our triage agent, and we got a response from the billing agent. Same thing happening with the refund agent. We give it an input, and we get a response. And now our triage agent takes those 2 responses and generates a human-readable response that composes those two responses together. So a nice way to do that with connected agents and agents as plugins. But I want to talk about more advanced multi-agent systems. So I'm going to move over here to this one. And I want to talk about AutoGen and semantic kernel. For those of you that aren't aware, we have a couple frameworks for building multi-agent systems at Microsoft, client-side frameworks. We have AutoGen, which is our research framework, focused mainly on multi-agent systems. And we have Semantic Kernel, which is our AI application, our production-ready stable framework. So all the examples I showed here were in Semantic Kernel. But what we're doing is we're actually converging those two frameworks. And we've already done a bunch of the work to converge them, kind of at that lower level. And today, actually, the runtime for multi-agent systems in Semantic Kernel is actually the same runtime that's in AutoGen. So we've done that work under the covers. And with the next versions of these libraries, we're going to converge the API surface as well. So we'll just have one of these pretty soon. And if you're starting your projects today, recommendation, use Semantic Kernel. That's our production-ready supported framework. And we're bringing all the stuff from AutoGen into there. And we'll have one place where everyone can build their multi-agent systems and orchestrate them from the client. So you guys have been waiting, right? Thanks, Rory. Yep. It's been a long time coming, but we're really happy with the work the AutoGen team is doing, and we're happy to bring that in to Semantic Kernel and have a single library that we can use. So what does it mean, though? So I talked about having a single runtime between the two. Well, what it means is we can take all those patterns that you may have been using already in AutoGen, and we can now run them in Semantic Kernel. So we have a bunch of patterns that are kind of built on Rails within Semantic Kernel. You can build your own patterns, but these are ones that we supply. Fairly obvious what some of these do. Sequential, you have one agent talk to another agent. The results of one agent goes to the next agent and the next agent. And you connect them together, and they go in sequence. Sequential. Concurrent, that's what you just saw. All the agents, working in parallel, and then the result comes back once they've all completed. Handoff, a little bit interesting. You have like a shared context, and so kind of the brain of the agent gets handed off between different agents. This is good when you kind of have a sequential flow, but you want to have the same state between them. Group chat, this is a very powerful one to kind of sprinkle in your more complex processes where you have two agents talk back and forth. This is kind of what Salman was showing us, where you have these agents talking back and forth and iterating. And often you can do like an author-critic pattern or a worker-reviewer pattern where one agent comes up with some result, and then you have a critic, gives it feedback. And you have these agents go 2, 3, 10, 20 iterations and significantly improve the results over time that you get out of them. And then two other more complex flows, Magentic, which I'll talk about in a second, and then workflow processes. So this is using our process framework directly to build custom workflows. So let's take a look at what that looks like. Let's dive into Magentic specifically. So Salman talked about Magentic. Magentic 1 is a pattern that was developed by Microsoft Research, by the AutoGen team. And really what it is kind of Salman was mentioning, was it's a pattern where your coordinator agent gets a task, and it generates a task ledger out of that. And it works its way through the task ledger, and it checks to see if the agents it's working with are making progress towards completing that goal. And if it doesn't, it'll go back and it'll change the plan, and it'll try something else. So you end up with these kind of self-healing processes. And what I want to show you, actually, Salman showed you a demo of that working. I'm going to show you guys a demo of it not working, which I think is really interesting. So this is a recording I did. This is an earlier .NET version of Magentic 1 running on Semantic Kernel. And what's really interesting here is you can see how these systems are made. We have these patterns that you can plug into. So I'm creating an agent. This one's got a coder agent and a researcher agent and an orchestrator agent. I think there's a few more agents in here as well. And we create this agent team. And then we register that team together. We put all those agents together. So we have our coordinator, and then we have each of these sub-agents that are used by the coordinator agent. And so I'm going to run this. And this instance where I ran it, I'm asking it kind of a more complex question: calculate the distribution of the top 20 largest cities in the USA. And we initiate that task. And so now what it's doing is what we saw in that flow chart. It's building that plan. It's figuring out, it's analyzed the task. It's kind of building a plan out of it. You'll see a couple responses going back and forth here with token usage. And then now that it's generated a plan, it's going to pick the agents it wants to use to accomplish that plan. And so it's now built this plan where it needs to search and retrieve the latest data from the web. It needs to do some math on that, and then it's going to generate a chart at the end. But what the Magentic system didn't know is that I didn't configure one of the agents properly. So there's agents here. There's an agent going up to the web, searching for data. There's now a coding agent that's figuring out the distribution of the population of these cities. But the agent that is supposed to generate the chart at the end of it, the visualization, I actually didn't configure properly when I was recording this demo. So you'll see here, it'll come back, and it'll say, please create a visualization for this population distribution. And it says, I can't do it. And that was my fault. That was user error. I didn't configure the agent properly. And so it'll go back to the orchestrator agent, and the orchestrator agent will try again. It'll say, please can you create this visualization? It sends this back. It evaluates its plan. It sends it back. And our illustrator agent again says, hey, I can't do it. I can't produce the visual representation. I just keep getting an error code. I don't know what to do to fix this. So it's now tried twice. And so now it goes back to the orchestrator agent. The orchestrator says, OK, this agent is not working. I'm going to try a different plan. And so it generates a new plan here. And we'll see, hopefully in a second, well, I know what's going to happen because this is a recording, is that it actually asks a different agent to generate an ASCII visualization. So it didn't generate a chart. You couldn't do it with an image, but it was able to figure something out. So that's a really powerful way, and I think it illustrates really nicely these cases where we have this LLM-driven flow. And of course, you want this often. You want this kind of creativity to come from your agent systems, but of course, sometimes you don't. Sometimes you want a process-driven flow. And so I will touch on that real quick. I know we're running out of time, so I'm just going to flip over actually to number 2 here real quick. So this is actually the sample that Scott Hanselman and I wrote for his session yesterday, where he has a process that is post-processing his podcasts. So there it goes. So if we look at this process here, very simple process, not as complex as the one Salman showed, but it's kind of going through. And one of the nice things when you're building stuff in Process Framework and Semantic Kernel is you can have some of these steps in the process be, what we have on the right here is our process. We're going step after step. If we run this, I'll just do a .NET run here real quick. Whoops. Not found .NET run. Oh my goodness. Okay, so if you run this, it's going to go and it's going to post-process the podcast, the same as we saw kind of yesterday. And one of the nice things with building a process framework with Semantic Kernel, there's cases where you need agents, there's cases where you need AI. So if we look, and there's cases where you just want to run code. So you can see here each of these steps, we have some of them are agents, some of them are just services that we have. So we talk to our transcription service, which isn't an agent, it's just a service that we have available. And we're able to run all those things in code and have these very kind of complex business processes that combine agentic steps and non-agentic steps. And so we can see when this is running, the other thing I want to show you guys that Scott didn't get to show you is being able to see telemetry coming out of the system. So if I do a search here, actually I'll just do the ones already loaded. Since the process is still going, we can hook up our process framework to Application Insights. And if I click on this, we can see all of our agents running. This is one I did earlier today. We can see our timeline of agents running, and we can see, okay, our processing or getting the transcript, that took a long time. Then our generating our nodes took a little bit less time. We can drill in, and we can see all the data that's coming off of our agent system here in Application Insights. Okay. One last thing I want to show real quick. I don't have time. I don't know if I'll have time to show the whole thing, but we also have A to A support within Semantic Kernel. This is brand new, and actually we haven't pushed it to main yet. We were kind of waiting some things. I don't know if you guys saw the A to A actually did a big update today if you're following it closely. So we're going to fix that and we'll get it up into main. But you can now build A to A servers within Semantic Kernel, and you can connect to A to A agents from Semantic Kernel as well. So that's a sample we have here. I don't think I have time to show it. We're kind of running out of time. But very easy to create your agents with Semantic Kernel. You just, your A to A endpoints. You can just use if you're using ASP.NET Core, if you're familiar with that, you can map your A to A endpoint, and now you can host those directly in Semantic Kernel. And of course, you can connect to them very easily as well by just specifying the endpoint. And we will go and retrieve, where do I do that? Here somewhere, I think it's in here. And then we will go and retrieve the endpoints for that A to A server, and then you can talk to them directly. Okay, I'm going to go back over to slides, and we're going to wrap up real quick. Okay, let's do this. Okay, I do want to talk about a customer, ASUS, kindly provided us a case study where they've been able to build an assistant using Azure OpenAI service and PTUs to provision their assistant. And then now their next generation assistant they're working on uses Semantic Kernel and agent service and actually voice agents to create an interactive flow. Ooh, it's playing sound. So you can see they're able to kind of connect these things together. They have a multi-agent system. You can see the diagram here on the left. One thing that I think is really interesting, too, that they did with their MCP servers is they put them behind API management. This is a great way if you're using these MCP servers and you want to control which agents and which processes have control of them, put them behind APM. OK, wrapping up. We talked about single agents in the agent service. We talked about single agents semantic kernel. We talked about multi-agents in the service. We talked about orchestrating them with semantic kernel. And we talked about the difference between process-driven flow, directed flow, workflows, and LLM, non-deterministic flow. And we had a demo fail. That was our demo fail. We had a connectivity fail.
Issues, yeah.
I think all our demos worked. I think we were pretty good there. And so to bring it all together, we saw Azure AI Foundry as a service to build your agents. You can select different models. You can select different tools. You can connect to different resources. You can store things in Cosmos DB. You can store things and you can use Azure AI Search. You can use grounding with Bing, which we showed. And then you can use semantic kernel to connect agents into the open agentic web with external API support, MCP servers, A2A servers, and then also connect into M365 ecosystem through the M365 Agent SDK, which allows you to now get your agents hosted from Foundry into Teams, into M365 Copilot, into Messenger, into Twilio, all these places. OK, I'm about to be hooked off stage. Thank you, everyone. Bunch more sessions available. Thank you for your time.
Thank you.
And one last thing, all the demos for today are available. Oh, they kicked us off. There's a QR code. Let me see if I can go back. No, they're not going to let me. All right, go to the build site where you can see our feedback and you can see links to our source code there.